Welcome back to Jackson Square. Today we're looking at TEK 6.7a, which says, I can generate equivalent numerical expressions using order of operation, including whole number exponents and prime factorization. Today we're going to be putting our emphasis on order of operations with exponents. So typically we've heard PEMDAS, please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, and subtraction. We're going to talk about GEMDAS because as you get older and we're moving more and more into algebra, we're going to have different grouping symbols besides just parentheses. So we're going to start with our G at the top, and our G stands for grouping symbols. Then followed the G, we have our E. And our E is for exponents. Then we have multiplication is the next step, and then division. And I want you to notice there's an asterisk there. That asterisk means first come, first serve, or we typically hear from left to right. So when you're walking down your problem from left to right, first come, first serve. So whoever's in line first is who you serve first. And we'll talk about that when we get to the example. After multiplication and division step, we have addition and subtraction, where you also see that asterisk there. That means first come, first serve. And again, we know that we typically say that is from left to right. So let me just pop in my words here. All right, so we have grouping, exponents, multiplication, division, first come, first serve, addition and subtraction, first come, first serve. Let's look at the example here. So in our problem, we have 9 divided by 3 plus the sum of 4 squared and 2 plus 3 times x, 3 times 5, 3 times 5. Okay. Grouping, we're looking for any grouping symbols. And when we say grouping symbols, that means parentheses, brackets, or braces. And I'm going to go into more detail in a second. In this particular problem, we have parentheses. So inside of the parentheses, we have 4 squared plus 2. Well, before we can combine 2 with 4 squared, we have to do the exponents. So we'd actually do the exponent part first. 4 squared means I'm going to multiply 4 times itself. That means I'm going to have 2 4s. So 4 times 4 will become 16, as you see in the next step. And then 16 plus 2 will become 18. So then we're done with everything in parentheses, okay? We already did our exponents part, and now we will move to multiplication and division. So remember I talked about walking down that street, first come, first serve. So when you're walking down the street, you're walking left to right. So as we're walking down the street, left to right, the first thing I see is division, okay? First come, first serve. It's not multiplication, then division. It's multiplication or division. So whichever one of those operations you see first, that comes first in the line, is what you serve first. So I have 9 divided by 3. 9 divided by 3 will become 3. And then in my next line, I see that I also have multiplication. Well, it's at the back of the line, so it's going to get served last, right? So 3 times 5 will become 15. Then after that, we come back down, and the same thing with addition and or subtraction. I have 3 plus 18, so that gets served first. Then I have 21 plus 15 to finish off my problem. So let's look at grouping symbols. Again, we talked about grouping symbols can be parentheses, brackets, or braces. You will definitely see parentheses and brackets. You may not see braces this particular year, but know that there are options. So let's talk about what is not a grouping symbol. This is not a grouping symbol, okay? This is not a grouping. This is just showing that 14 is negative. It's enclosing that negative sign with 14. That's not a grouping symbol. There's no operation to do in here. So you would do nothing, not a grouping symbol, okay? That does not qualify as a grouping symbol. No, no, no. That is not a grouping symbol. Okay? What is a grouping symbol? This is a grouping symbol. Okay? So inside, we see that -3 is enclosed in parentheses. However, that -3 is being combined with the +2. There has to be an operation symbol, addition, multiplication, division, or subtraction inside those brackets or braces or grouping symbols to make it grouping, okay? There's an addition sign here. In this one, there's none. There's no symbol, okay? Not grouping. What about here? This one is interesting. We have 5 plus 7, and it's also, that is being added or combined with 12, okay? So this has braces and parentheses. Whenever you have something like this, we want to solve it from the inside out, okay? Solve from the inside out. And here's another little way to remember, inside out, inside out. Okay, so I would combine 5 and 7 to get 12, and then I would add that 12 to the other 12. Do the inside bracket or grouping symbol, and then go out. Here's another look at this, another way we could see it. Again, we're going to go from the inside out. So I would combine 1 and -2. And then take that after I divide 3 by 3, and I would combine those. So you can have multiple things going on inside of your grouping symbols, but you're going to start from the inside out. Okay, so I would start here. Then after I do that, I would go here, and then I would take those two entities and combine them. So I hope that makes sense. If you have more questions, definitely ask in class or in your Zoom, and we will clarify that. So let's jump right in and talk about exponents. Exponents are new to us, right? So let's learn all about them. So there are two parts to an exponent. The first part is the base. The base is the number being multiplied by itself. It's the number that's being multiplied by itself. So for example, 9 raised to the second power, 9 is the base. 9 is the base. 6 raised to the fourth power, 6 is the base. Exponent. The exponent determines the number of times the base is multiplied by itself. So the number is going to be multiplied times itself, okay? That base number is going to be multiplied times itself. So, for example, 3 to the fifth power, 5 is the exponent. 5 is your exponent. It's telling me how many 3s, how many times I'm going to multiply 3 times itself. In the example, 2 to the seventh power, 7 is the exponent. Things we need to know. Any number raised to the second power is called squared. Any number raised to the second power is called squared. The reason why it's called squared is because we're talking about dimensions. So this piece of paper only has 2 dimensions, length and width. So if we are raising something to the second power, think about when you build a square. If I had some blocks and I was building a square, if I had a 9 by 9, 9 is my length, 9 is my width, then that makes a perfect square. It's only 2 dimensions, but it would be 9 squared because it makes a perfect square. So anything raised to the second power is called squared. So let's go back and read some of these other ones. How is this read? So here we have 6 raised to the fourth power. It's read 6 to the fourth power. Here we had 9 raised to the second power. You can read it as 9 raised to the second power, or you can read it as 9 squared, because it's what? 2 dimensions, length and width. If we have something raised to the third power, it is also read differently. So if we had 8 raised to the third power, it is also known as 8 cubed, because we would have length of 8, width of 8, and then a height of 8. So we would have 3 dimensions, so it would be cubed. So anytime something's raised to the second power, it's squared. Anytime it's raised to the third power, it's cubed, okay? So just some interesting tidbits to know about exponents. So let's really talk about what an exponent is. So we talked about that an exponent has a base, and we talked about that the number on top is called the exponent, and it tells me how many times I'm multiplying that base times itself. So here's an example. In 3 to the 4th power, what does 3 to the 4th power mean? 3 to the 4th power means I'm going to multiply 3 times itself 4 times. Okay, so that's going to be 3 times 3 times 3 times 3. That's what that means, okay? 7 to the 3rd power means 7 times 7 times 7. In this example, 3 to the 4th power, my base is 3. And my exponent is 4. In 7 to the 3rd power, my 7 is my base, and my exponent is 3. So this is how you write them in expanded form. So this is in exponential form. This is expanded form. So we're going to expand it out. 3 raised to the 4th power means 3 times 3 times 3 times 3. 7 to the 3rd power means 7 times 7 times 7. Now, we need to know any and all numbers raised to the 0 power will be equal 1, no matter what. So if I had 9 to the 1st power, 9 to the 0 power, that would equal 1, okay? And there's a long, drawn-out explanation for that. If you're interested, I can attach a video for you about that. But any number raised to the 0 power, like here, 12 to the 0 power, the answer is just going to be 1. In the same, in the same matter or fact or category, any number raised to the 1st power is just the number. So if I had 3 raised to the 1st power, that means 3 is only multiplied times itself once, or 3 is 3. So it's going to be the number. So anytime a base is raised to a power of 1, it's that number. So this was written in expanded form. So things we need to know about exponents. Exponents are multiplication, okay? Multiplication. It is not addition. A lot of times kids will add and you will get your answers wrong. Please do not multiply the base times the exponent. If you multiply the base times the exponent, you will be wrong probably 80–90% of the time. 3 raised to the 4th power is not 3 times 4. The answer is not 12. 7 to the raised to the 3rd power is not 7 times 3. The answer is not 21. So please do not do that to yourselves, because you're going to get wrong every time. Do not get in a crunch. Do not get nervous and do it. You're going to get it wrong. Okay? So what is 3 raised to the 4th power? 3 raised to the 4th power is actually 3 times 3, which is 9, and 3 times 3, which is 9, which will give you 81. Okay? So the answer is actually 81. It is not 12. That is very far apart. 12 and 81, no, not even close. Okay, 3 times 3 is 9, and 3 times 3 is 9, and 9 times 9 is 81. Okay, 7 times 7 is 49, and then 49 times 7, I'm going to cheat and use my calculator, y'all, because I don't know. 49 times 7 is 343, okay? So 7 to the 3rd power is 343. It is not 21. 343 is definitely not 21. So please do not try to multiply the base times the exponent, because like I said, you will be wrong every single time pretty much, okay? Every single time. So I want you to pause and practice 9 squared, 8 to the 9th power, and 12 to the 0 power. Write them in expanded form and then multiply them out and get an answer. Pause and practice here. Welcome back. So hopefully that was not too much trouble for you guys and you got it. So 9 squared, 9 is our base. Our exponent is 2. That means 9 times 9, which is 81. Please, I hope you didn't put 18. If you multiply 9 times 2 and got 18, don't do it. 8 to the 9th power, our base is 8. Our exponent is 9. I just like change my font. It's so many 8s. It's like 8 times 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 8, which is a ridiculous answer of 134,217,728. Yeah, I hope you use your calculator because I did. I couldn't. 8 times 8 is 64, and 8 times 8 is 64, and 64 times 64 is some ridiculous number, right? And then you get that, and you multiply times another 64, and another. That's a huge number, okay? Then we have 12 to the 0 power. The base is 12. Our exponent is 0. I told you any number raised to the 0 power equals uno. So you should have just put 1 there, right? So hopefully that was easy. Let's see what else we have in store for you. So here you have intro to exponents continued. Expanded form shows the full multiplication of the base. 6 to the third, or 6 cubed, is written as 6 times 6 times 6. 3 to the 6th power is written as 3 times 3 times 3 times 3 times 3. We kind of talked about this already. Standard form, when a number is raised to a power or when the number is simplified, then it's called standard form. So what you're going to see when you're doing order of operation, you're going to see it in standard form. And anytime you're going to solve it, you're going to write it out in an expanded form to be able to get your product. So you're going to come in and you're going to do these problems below. It's going across in rows. So here I have 5 times 5 times 5. So in exponential form, that would be 5 raised to the 3rd power. And you can put the caret. That little caret means that it's raised to that power. I'm going to make this smaller. So 5 raised to the 3rd power. In standard form, we're going to simplify this. So 5 times 5 is 25. And then 25 times 5 will give me 125. That's just one of those exponents I just know off the top of my head because it's common. So remember, 5 to the 3rd power is 125. The next one, I have 36. So I think that I'm going to put 36 is 6 times 6 to give me 36. This font is too big, and I'm going to put an X. So 6 times 6 is 36. So that would be 6 raised to the 2nd power, or 6 squared. So what I want you guys to do is you're going to pause and practice the next 3. Stopped off here at 7 cubed. Hopefully you wrote 7 times 7 times 7, which is 343. We know that one already. 9 to the 1st power is just 9. Then we have 2 to the 4th power, which is 2 times 2 times 2 times 2, which hopefully you got was 16. So let's practice some more.